The best time to investigate an incident is before it happens. If you can do that, then you've
Yeah.
prevented the potential that someone could get hurt.
Okay, welcome to the Electrical Safety Podcast. I'm your host, John Travis, and today we have a special guest joining us, Lanny Floyd. With an impressive career spanning several decades, Lanny is an expert in electrical safety. His leadership led to an incredible 21 years of zero electrically related fatalities for both employees and contractors at DuPont. And he also is an accomplished author, speaker, contributing significantly to the advancement of electrical safety practices. Stay tuned as we reflect on his 50-year journey in electrical safety. And Lanny,
Well, John, I'm really happy to be here. Your work in helping advance the practice of electrical safety has been really impressive, and it's just a pleasure being able to join you today.
oh, well, thank you. I don't think I can speak anything to the 50 years that you've put in, and that's probably where we want to start. I always ask everybody to kind of I always find it interesting how people even find their way into electrical safety. So, I think a lot of people like to kind of hear your backstory and how you got started. And
Well, I'll try to keep it as short as I can. When I was 9 years old, my dad entered an electrician apprentice program, and so when I was in my 10, 11-year-old time frame, I saw him and his friends as they were studying and practicing and preparing for tests and practical demonstration type things in their apprentice program. And so that kind of gave me some insight when I was very young. And then when I was about 16, when I was 16 years old, I went to work for the electrical distribution company that he did business with. And I was just in like sales and general handy person around the shop
Mhm.
there. But again, that expanded my exposure to electrical uh, work, electricians, and some of the hazards. And then when I was 19, I actually went to work for the DuPont company as an electrical engineering intern. And DuPont was throughout the 20th and 19th century, DuPont was a pace setter in occupational safety. And so it was a world leader. But about a month after I started working there, our manager called us together with some bad news that there'd been a fatality. Turned out it was an electrical fatality, a electrocution. And I didn't realize it at the time, but that was a turning point for me when I was still a teenager, to become interested
Mhm.
in how these accidents happen. And as the years went on, I became more interested, involved in how do you prevent them. Uh, and so that's what I've been doing for the past over 40 years now, is exploring how you prevent electrical accidents. My work, started before there was an OSHA regulation on electrical safety, before there was an FPA 70, or now in Canada Z462. So
Mhm.
the thought process on hazard identification and risk identification, risk assessment, and risk management, for my own experience, predate what most people kind of take for granted today, and that's the what the OSHA regulations require in the U.S., what the industry standards require, and so all of my work has been about looking at the residual risk that exists after you have complied with the regulations and standards. There's always risk.
Mhm.
Sometimes you can't reduce it anymore, but often with a few questions and a few knowledgeable people involved, you can find ways to reduce that risk even further than what the code standards and regulations call for.
Yeah. Yeah. Hoping to dig into that a little bit more here, but just kind of as you mentioned that you even got started in this, before OSHA and NFPA and all of that came along. I find that really interesting. Like for me, I'm relatively new in the electrical safety space, say 10, 15 years. And, I got started because my boss, I worked at a mining company. My boss came to me and said, "Hey, we want somebody to figure out this electrical safety stuff." Or at that time, he said
Yeah.
arc flash stuff, and that was pretty much the start for me. And then, um, but I just looking through the article you wrote recently, and the note here, I thought this was pretty interesting. After the 3 Mile Island nuclear accident, and the comment here from President Jimmy Carter, um, they are convinced, or we are convinced, that regulations alone cannot assure safety, and then kind of focusing in on absorbing concern with safety, and then you kind of took that into the electrical space. Um, I still think people struggle with that a lot. Like, so could you kind of talk about the difference, the way you see it, between conformance or compliance versus, you know, absorbing yourself with safety?
Well, certainly, when in the U.S., when the OSHA regulation was put into law, it was in late 1970, there had been over 15,000 occupational fatalities in the U.S. the year before. That's from all causes, not just electrical. Last year,
Wow.
there was less than 5,000. So the regulatory process and the industry standards that the regulatory process uh, kind of spawned or nurtured to come along, such as NFPA 70 for electrical safety, have made a big difference. However, as the report on the 3 Mile Island accident pointed out, one of the underlying causes of that, and again, the nuclear industry is heavily regulated, even back then at that time.
Mhm.
It is one of the most regulated uh, industries ever because the consequences of
Mhm.
a nuclear accident, whether it's private industry such as a nuclear power station or a military accident involving nuclear weapons, the consequences are absolutely unthinkable. Uh, and
Mhm.
so the amount of regulations that have gone into nuclear safety is awesome. But this statement in that report pointed out that you can't regulate everything. There are things that come up in everyday work activity that get outside the boundary of what the regulation is addressing. And
Mhm.
what I recognized back then was, well, that if that's probably true with electrical safety too. So I started looking at, well, how do you find that what I call residual risk or the hidden danger that
Mhm.
exists after you have complied with and done everything that the regulations or standards say you need to do. And again, as I said earlier, many times there's no more you can do. But often, and in many of
Right.
the fatalities and accidents that I've investigated, there was always one more thing or two more things that could have been done, real easy, not expensive,
Mhm.
not overwhelming, that could have made a difference.
So would you say, like, a way to think about this, um, when you look at the regulations and compliance, that might be the very obvious risk with whatever job you're doing, and the residual risk maybe not so obvious. Is that a good way to look at it, or am I?
Well, in many cases it may not be obvious, but once you stop and ask a few questions, it may become very obvious that there's we've been accepting a risk just
Mhm.
because we believe that complying with the regulation or the standard achieve the level of safety that we want. And again, I want to be careful with what I'm saying here. I'm not in any way. I'm not saying that the regulations and standards are deficient uh, because, as I said, they have definitely demonstrated the ability to save lives. But what is the issue? I think is that people come to the conclusion that that's all they have to do, and
Mhm.
often. And many times you can get away with just doing them. And again, the regulations and standards if you talk to anyone who's knowledgeable that's been involved in the development of the OSHA regulations or the industry standards, they'll tell you that these are the minimum requirements. These are
Mm.
the things that everybody should be doing, but it doesn't. What's not obvious is that there's again the residual risk. There's risks that may still exist
Mhm.
that that if you just ask the question, well, now that I've complied with the requirements, it could even be the requirements of your own safety program in your own company. There may be residual
Yeah.
risk after you comply with that. So again, the simple asking, well, where's the hazard now? Maybe it's behind that door. Oh, well, how are we going to make sure that no one opens that door or take that cover off or lift that barrier?
Mhm.
Uh, if we think, well, we'll just depend on people doing the right thing. Well, that is important that people know what to do. They do the right thing, but people are human and humans make mistakes. Even your best knowledgeable, most competent person can make a mistake. They could miss some information. They could misread an instruction. They can overlook an obvious sign. They could be distracted. And so the residual risk is about helping make sure that the everything you put in place to safeguard people, that you recognize how those safeguards could fail.
Yeah. Do you have a really good, maybe a story or an example of a it could be an incident you were involved in or one that you just reviewed afterward where, once you kinda looked at it, you recognize that, "Oh, there was the residual risk here, and that's sort of what got them," or something like that.
Well, first thing I'll say to answer it's not really the answer to your question, but the best time to investigate an incident is before it happens. Okay. If you can do that, then you've
Yeah.
prevented the potential that someone could get hurt. So the story that I'd share with you on that is I was at one point in my career, I was the supervisor for an electric power system for an industrial facility. I was responsible for the operation and maintenance of a system that consisted of 12 kV, 5 kV, and 480 volt equipment. And it was on an existing facility that we just had this new project, had just installed it, and I was involved. I had planned the first outage, the first shutdown to do maintenance and inspection.
Mhm.
And so we'd gone through and we did the lockout. I think this was a very complicated system because it was in a continuous operation facility. And so there was tremendous amount of redundancy and ways to backfeed and that sort of thing. So the lockout on one substation, I think was 36 lockout points. And I had 9 sets of safety grounds installed. I had it on the 12 kV system, many on the 480 volt. And so we had it all locked out. I had a crew of 5 electricians working on it. And so we were into it. We were taking off covers, doing inspections. And then I looked into the rear of a 12 kV circuit breaker cell. And at the back of the cell was this shutter that when the breaker rolled in, the shutter would raise, allow the breaker to plug into the stack. And I looked at that and I thought, what operates that shutter? And then I realized that when the breaker rolls in, it pushes the lever along the side. And I looked down and I thought, all a person has to do is push down on that lever and they raise that shutter and they're exposed to 12 kV. All right. Now, so I called out to my crew. I said, look, guys, we're going to stop the job. And I pointed out what my concern was. And they said, we'll get back together after lunch. It was about time to break for lunch. Well, after lunch, they said, well, boss, we got it figured out. We know what to do. Said, all we need is a 12-inch length of chain. We can wrap it around that lever onto this stationary point, put a lock on it, and it becomes another lockout point for this shutdown. Now, the codes and standards didn't
Mhm.
require that. If you look at what requires an
Right.
electrically safe work condition, it's the points of energy supply.
Yeah.
We had those already had those locked out. We had everything done according to the
Mhm.
regulations and standards. But just looking at that gear and asking, how could someone raise that shutter? Open up, and it costs nothing to, to address it. And that's my point on this, that
Mhm.
many of the additional measures you can take, uh, may not involve any significant amount of money. It's not like, okay, let's wear 2 layers of FR clothing. That's not what I'm talking about. It's about,
Yeah.
looking at where can things go wrong and how can we address it.
Yeah. No, that is a really good example. Um, and that is the thing. I know I've had different clients over the years who will point blank ask, um, where in the regulations does it
Right.
say we need to do this? And that's always frustrating because you feel like you got there because they wanted to improve safety. And so to me, that question shouldn't even be asked. It should just be, well, how do we make this as reasonably safe as possible? Not where in the regulations does
Yeah, I
it
have a
say we have
story
to do
related
that?
to that, and that's the use of ground fault circuit interrupters. Someone called me one time and says, Does the code say I have to install a GFCI at this particular location?" I said, "That's not the right
Hmm.
question." I said, the right question is, will installing a GFCI in that location make the workplace safer?" All right. That's the right question. And again, that's an example of where we have this compliance culture that if the code doesn't require it, then we're okay. Well, that may not be
Hmm.
true. Again, if you look at the evolution of the requirements of GFCIs in the National Electrical Code going back to 1970, it only required it in bathrooms, I think, was the first requirement. Now there's probably,
Yeah.
it's a page full of places that a GFCI is required. All those places existed back in 1970, but we just
Mhm.
didn't recognize that a GFCI would make it safer if we put it in those locations too. So again, that's a part of the trap of the compliance-based approach. We have to, that's the minimum. The compliance is the minimum. We've got to look beyond that to see how we can further reduce risk.
Yeah, it's really like if you've identified a hazard, it doesn't matter what the regulations or codes say. The right thing to do is to
How do we mitigate? How do we reduce the likelihood that someone could be exposed to that hazard?
Mhm.
And again, to ask that question before the accident happened is a lot more effective than after it happens.
So for somebody who's trying to maybe take that next step, they've done the typical compliance things. I know you have a number of questions that you can ask yourself in order to see beyond compliance. What's the thought process there? What are some of those questions
Well,
that
a
you can?
simple way, again, electrical safety is not simple. Okay. Not safety is not simple. But a simple way to get started and to be thinking about how to look for that residual risk is, again, after whatever the job is. I use the lockout tagout example, but it may be involve something entirely different. That maybe doesn't involve lockout tagout at all. But uh, you know, after you've done everything that the regulations require, then a simple question is, well, where is the hazard now? Maybe it's on the line side of the switch, or maybe it's 15 feet in the air on an overhead line, or
Mhm.
maybe it's behind this cover. And so once you're clear where the hazard is, then you can ask, well, what controls do we have in place? Well, we got the locks, we have enclosures, we got the doors are closed, they're sealed up, the bolts are shut, and you know the overhead line is 15 feet in the air, we can't reach it. Well, then you ask, well, how could those controls fail? That's the third question. Okay, how could
Mhm.
controls fail? And, for an overhead line, then the controls fail if someone has something long in their hands that's conductive, like a ladder or a piece of pipe or a vehicle like a crane or a cherry picker. Uh, uh, then that control, that 15-foot space, is no longer effective. Someone can reach it.
Mhm.
If you're depending on covers on a switchgear to isolate a person from the electrical hazard, then how could a person Why would a person take a cover off? I had a case one time where a guy dropped a wrench and it went down a little through a crack into the switch gear. So his focus switched from doing whatever he was doing to retrieving. Then it switched over to retrieving the tool.
Mhm.
And so he said, "Oh, all I got to do is take this cover off, and I can get the tool." Well, what he didn't recognize was taking that cover off exposed him to a high voltage bus bar, and he made
Mhm.
contact with that. And again, you could step back and say, well, what can we do to prevent that? Well, some people I've seen examples where people identify those covers that cannot be removed on a particular task. They put some red tape, put a big red X, or they put red tape over all the bolts on the cover uh, as a signal, as a warning
Mhm.
that hey, don't touch this, don't take it off, don't operate that, don't remove this bolt. Again, those are simple things you can do to go beyond the minimum requirements.
Maybe switching gears a little bit, I know in some of the things I read, that you've been talking about and writing about lately, uh, that stood out to me was, um, eliminating the risk at the design stage. And I know you mentioned it a few times. I don't know how much you've thought about it, but, to me, that's something even today, reviewing new facilities and new installations, and I think, oh, the person that did this wasn't thinking about electrical safety at all. They just built it the same way they always build it. And, sometimes they do the right thing, but even today, I still find I see that all over the place. They're not thinking about designing in uh,
Yeah.
different mitigation techniques.
Yeah, that's a very important question. And I think it's one of the key things that we can think about to reduce our risk from electrical injury. And I'll use an arc flash example. I know it's something you're very familiar with. The, uh, the codes in the US, the National Electrical Code, in Canada, the Canadian Electrical Code, they require overcurrent protection for equipment. And there are rules on how you select fuses or circuit breaker settings to protect the equipment, and that's to minimize damage to the equipment. Well, when arc flash awareness came about back in the mid 1990s, was when it first became a topic of in the mainstream of electrical safety. Uh, we started looking at, well, maybe we could do something different with that fuse. And that fuse now becomes not just an equipment protection device, but becomes a personnel protection device. So we found, and
Mm.
others throughout industry, the equipment manufacturers, the fuse manufacturers, all came to a realization that there are techniques, engineering design techniques to select fuses and to set circuit breaker settings at a lower setting than is required to protect the equipment. And the lower we can set those devices, whether it's a fuse rating or a circuit breaker setting, uh, we reduce the incident energy if an arc flash occurs. Okay. So that's one design technique. And again, it's a no cost technique because it's not talking about adding
Mhm.
additional fuses or additional circuit breakers. It's just about the selection of what you're going to be using anyway. And again, the
Mhm.
codes and regulations don't really address that. Uh, but it's a prevention through design technique. The another example that is a very simple one, and this is important when you're specifying new equipment. It's kind of hard to do on a to retrofit this, but I'll call them touch safe terminals. They are terminals that are designed so that you can't touch the screw, the conductive part with your finger, with the tip of your finger.
Mhm.
And it's been a common design practice in Europe for decades, but it's only recently becoming, and it may be more common in Canada than it is in the United States. But if you can have your terminals, whether it's terminal strips or terminals on a relay block or terminals on any component that's in that electrical equipment, if it's designed so that if you can't touch an energized part with your finger, that is a huge advancement in reducing risk for electric shock and arc flash, because you
Hmm.
can initiate an arc flash by shorting out something like a terminal to ground or something like that. Or it could
Yeah.
be when I talk about the finger, but also that prevents a tool or any other metallic object or most metallic objects from coming in contact with that conductive part on that terminal. And those are just two
Yeah.
examples, but again, the co the codes and regulations around installation, like the National Electrical Code, are the minimum requirements to assure the safety of the occupants of the facility. That's what the code is really about. And, so there's not a whole lot in the code, that is about safety to the installer. There's some, but most of the requirements in the code are about the safety of the occupants, the future occupants. And so the requirements of the code, you could be fully compliant with the installation requirements and overlook options you could have done to protect the people that install and maintain that facility.
Yeah. That's kind of where, you kind of have maybe three documents, or at least in Canada, you do how to build it safely, how to work on it safely, and how to
Yes,
maintain it. But the trick is how do you fit all those together so when you design it, you're
yeah.
thinking about all of those three things, and that's
That's
probably
the
what
real
gets
nut.
missed.
Okay, that's the what we're trying to achieve is that, some people think, oh, well, our electrical safety program is based on the industry standard. We just copy that over into our procedures, or we send people to the training session for the industry standard, and okay, we've done it. But the reality is, your electrical safety program needs to incorporate information from many different sources. It gives them, as an example, NFPA 70E is primarily focused on industrial facilities, general industry. The National
Mhm.
Electrical Safety Code is focused primarily on electric utilities and telecommunication utilities. So if people get into the discussion, well, which standard do we use? Well, for most facilities, you
Mhm.
got to use both. And the reason is, uh, I said that fatality that I had, first experience when I was 19 years old, when I first started working as an intern, involved a plant supervisor who came in contact with a 230 kV distribution line, and it had to do with the clearance above the ground clearance. And so
Mhm.
we needed to understand that the utility standard is important to our electrical safety program. And, uh, and it's not just those two standards, but the National Electrical Code, the installation requirements. You mentioned the maintenance standard in U.S. We have NFPA 70B, the standard for electrical equipment maintenance. All those have to come together into your electrical safety program, and so you integrate these things in a way that makes sense for your facility, for your work environment. They may have to be stated differently than it's stated in the standard. It could be, maybe there's a nomenclature or word choice difference between the standard and what people are accustomed to in your facility. Well, you need to use what they're familiar with, what they understand and know. And so you can't just take the regulation or the standard and throw it at them and say, here, this is your electrical safety program. That's not enough.
Yeah,
That
which that probably happens.
Yeah, I've seen that happen, and I agree with you. I mean, the content of those standards are awesome. I mean, they save lives, but
Mhm.
to do it without customizing it to integrate with other standards and regulations is shortchanging, and it creates an illusion that you've got an effective program. When in reality,
Mhm.
you may have a lot of holes just in the basic minimum requirements.
So I know one thing you talk about is continuous improvement, and kind of creating and cultivating a continuous improvement environment around your electrical safety program. Um, what are some things that people could think about, you know, introducing into their own organizations to try to get
Mm.
to that?
Yeah, good question. Technology is always changing. I mean, uh, you know, so many things have come on the market in the last decade around electrical safety, and if you're not aware of it, you may miss an opportunity to incorporate it on your next project that you're whether you're a
Hmm.
design firm or an industrial end user. You need to be able to know what to ask for. Well, how can we adapt this to to new facilities? Sometimes maybe it makes sense to retrofit. uh, Often it's difficult to justify economically, uh, although there are cases where retrofits is certainly called for. But it's really a tragedy to have a new project, like an addition to your plant or an expansion or a new greenfield location, and you just replicate what you've done before without asking the question, what's new and different? How could we use that? Uh, And that's just on the technology side. There's so many other variables. The workforce is certainly different today than it was 25 years ago. People are being asked to do more. The equipment is more complex. There's a lot more black box type devices in our electrical equipment that, we hook up the wires to it and we're not really sure what goes on inside, and something comes out the other side and makes the motor run. Okay, but so those are significant changes, and we need to be asking ourselves: Are we staying up to speed in how we're training people, how we're designing the equipment? Maybe things have changed on the maintenance side. You know, there may be something different in the environment. Things are a little warmer today than they were 25 years ago. Does that impact maintenance requirements? I would say in some cases it probably does. So just
Yeah.
constant that mode of continuous improvement is it's a mindset that we're always looking for what's different. What's different today than it
Right.
was the last time we did this? Whether you're planning a job or you're planning a new project or you're training, retraining people today. If you're just doing the same training you did 3 years ago, you're probably missing some things.
Yeah. I mean, I remember back when I got started, I mentioned it was my boss that asked me to start looking into it, and I was at one division of a fairly large mining company. Um, but within 2 or 3 years, we actually had developed an electrical safety committee that I was part of, and you'd meet with all one or two representatives from each of the mines and different uh, facilities. Um, and in the beginning, it was let's create our electrical safety program from scratch, and then once we had it up and running, that group stayed together over the years. I was part of that for 9 years, and so you and I think that was an important part to our success was to continue to meet each year to see what's new, what are the changes in the regulations and that. Because if you just think that you can sort of build your program, set it and forget it, 10 years is going to go by and you're
Yeah,
going to be
we had
behind.
something very similar in DuPont. We back around 19 in the late 80s, we created an electrical safety network charged with continual improvement in our electrical safety program, and I had the pleasure and privilege of leading that effort for 25 years. When I left in 2014, there was as many new opportunities to improve our program as there were when we started in 1989. And it's all because the more you learn, the more you see, the more you understand what you don't know. And also, I mean, the power of the creativity of people that are knowledgeable, electricians, engineers, technicians,
Mhm.
come up with innovative ideas to do things better. And they share that, and we maybe massage it a little bit. So we're continually learning from each other on how to do common routine things we've done forever better.
Hmm.
That
Yeah.
electrical safety committee, as you describe, I think is really critical to ongoing improvement. Whether you're a big company or a small company, if you're a small organization, maybe there's a way to partner with other organizations, companies in your area.
Yeah, and that might be one of the things, like when you talk about compliance. Um, there are other companies and organizations that think, oh, well, we did an arc flash study, so we're compliant now. Or, oh, we sent our guys on training, therefore we're compliant. Um, and it's, if you get into an organization that has its own committee designated to electrical safety, that's exactly what's going to happen is the more they learn, the more they're going to realize they don't know and how big this thing really is. And you almost have to have that at every organization, that's
Yeah,
a certain size, I would say for sure. Yeah. So there was another interesting concept that I hadn't really thought about before, reading through some of your stuff, and was kind of I think it was the hard risk and the soft risk, if I
yes,
got that right. So could you take a couple of minutes just to kind of go through
sure. Uh,
that concept and what
what I
the
was the point on that was to show that risk occurs. There are opportunities to reduce risk occurs throughout the organization. It's not just the electrician standing in front of a motor control center about to perform a task. In that case, the door is open. There's energized parts, maybe 480 volts, maybe 5 kV. That's very obvious, real and present danger. And I call that a hard risk. How can we reduce exposure to a
Mhm,
hard risk, or how could we uh, improve that? A soft risk may be a manager making a decision on whether to approve the additional funds needed to provide an enhanced safety feature on a new project. His
mm,
or her decision will impact the risk of electrical injury for the entire duration of that installation, maybe 25, maybe 50 years. But it's not staring anyone right in the face like those bus bars
mhm,
are in the motor control center. I call that a soft risk. It's a you could whatever decision you can make, nothing bad's going to happen right away.
yep,
Maybe never, but perhaps one day someone could be doing a task and that little enhancement, maybe it's maintenance switch, maybe it's an additional barrier or barricade or something in some equipment. Uh, Maybe it's going beyond compliance on GFCI installations, for example. Uh, that the consequences of that decision likely won't be known for a long, long time. And that's what I call a soft risk. And that whether you're doing a job plan or preparing for a pre-job safety briefing, for example, or involved in a design review or specifying equipment, looking through the catalog and figuring out which model you want, which options you want. Those are all opportunities for risk. Whether you're designing a training program, you're delivering a training program, how you do that, you can reduce the
mhm.
risk that the people will be exposed to in the information that you provide them. And so, again, I call those soft risks.
I think for me anyway, brings kind of a lot of the points together that you've been talking here today, and, I guess at this point, I wanna be respectful of your time. We're probably running short on it. Is there anywhere that if people want to read some of your articles or get in touch with you, where's the best place for them to look you up?
Well, most of my articles that I've written are published through IEEE, and those articles are generally copyright protected. by IEEE. But as an author, I have the ability to provide single copies to anyone who asks me for them. So if anybody wants to
Okay.
reach out to me, uh, I have several email addresses, but maybe an easy one to remember is h.l.floyd, H.L. Floyd, at IEEE. That's IEEE .org. And I would be glad to have a discussion or share information. I worked for DuPont for 45 years, and I said that early in my career, I was studying and learning on how to prevent these accidents from happening. We had 12 electrocution fatalities in my first 25 years of my career. Uh, that may seem like a lot, but we had a workforce of 100,000 people, and 12 and 25 years was pretty much industry average at that time. Okay. Certainly,
Mhm.
if you've got a workforce of much smaller, then that number to be average would be much smaller, maybe even a fraction, a decimal point type thing. My last 20, we had zero. The last 23 years or so, we had zero. And so we share that bit of data to emphasize that we figured out how to do something differently. And that was to think about risk differently. And one aspect of that was to think about looking beyond compliance and being innovative in how you look for that hidden risk. But, ask those simple questions. How could those controls fail? And what could we do differently? And again, it was a little more complicated than that. And I certainly wasn't the only one involved. As I said, we had a very robust electrical safety committee working throughout this time. And together we were able to achieve, I think, an extraordinary breakthrough performance in preventing electrical injuries and fatalities.
Now that's incredible, and I think that is a fantastic point to end on. So I'll thank you again for joining me today. It was a pleasure.
Thank you,
And
John, and I
yeah,
wish the best to anyone who's listening to this podcast in your work to continually look for ways to improve your electrical safety program.
great. Thanks.